ECD117's BingRacer is a machine learning racer that learns to drive on its own through the AWS virtual platform. Here you can see the process that goes behind creating a new machine learning model. You can select the vehicle used, then set the hyperparameters, which affect the learning of the model, as well as setting the reward function, which chooses what the racer is going to prioritize during its learning. The simulation shown here shows the DeepRacer during the learning process. It chooses random actions from its action space and tests which ones work as it tries to stay on the track. A graph of the model's progress helps track its improvement from iteration to iteration. As fun as it is to watch the DeepRacer learn virtually, it's even better in person. At the end of training, we can evaluate the model on a new track to test how well it can adapt. Once a model has been evaluated adequately, we move on to the physical testing. This is my favorite part of the project, and when you really get to see the DeepRacers in action.
Physical testing is quite different from virtual testing. We need to concern about the network connection, testing environment, vehicle status, and batteries level. When we began our physical testing, we encountered some problems such as the battery was locked, the light of our testing environment was not bright enough, or having trouble accessing the DeepRacer's website for calibration. Before we actually test our DeepRacer on the physical track, we need to calibrate the maximum steering angle and the maximum speed of the vehicle, figure out the stop speed, and check if the motors are going forward or reverse. After calibration, we started our test with a low-speed model to see how it works on the track. Then we tested different models with different parameters and hyperparameters. Based on their performance on the actual track, we could determine which one is the best model. Then we focused on the best model, and our next phase of testing was going to optimize this model and keep playing with it.
The whole process started off slow when we first received our project because we had to figure out what road we were going to take to get it done. But once we got to the integration phase, everything started to fall into place as our design slowly came together. Of course, there were plenty of hurdles to overcome, but that's what made the whole process worthwhile in the end. For us, the biggest challenge had to be the translation of loading a virtual model into the physical environment. Uploading models to the DeepRacer was straightforward, but it took a while and a lot of testing in order to get the calibrations of the racer correct in order to finally get a successful run on the track. Overall, the senior design experience was very rewarding. Working on this project was a blast, our favorite moments being the construction of the track and of course the first completed lap. But aside from this, we certainly gained a lot of knowledge from the whole timeline of the project. Little details such as managing time properly and following a schedule definitely helped more than you would originally expect. Additionally, we learned a lot of technical skills such as how to create and compile formal documentation, as well as how to work together with others toward a common goal. In the end, senior design was no doubt a very positive experience, leaving us with invaluable knowledge that will help us as we move forward in our careers.